The Bohr's model of an atom, where each electron is only described by just one variable. Only the energy level is used to describe each electron in an atom, just one variable. This model works very well for any one electron system. What does that mean? It works for hydrogen because hydrogen has only one electron. It works for helium that has lost one electron, which means it now has only one electron. It works for lithium that has lost 2 electrons, and so on. Any one electron system will benefit greatly from the Bohr's model of an atom. However, this model of an atom fails for multi-electron systems. So it does not work for helium atom. It fails for lithium atom, beryllium atom, and all the other elements. The quantum mechanical model that was developed after the Bohr's model was very successful and is still very successful at explaining the chemical properties of all the elements in the periodic table. And the quantum mechanical model has a very basic difference from the Bohr's model in that it requires 4 variables instead of the one variable that is used in the Bohr's model of an atom. These variables are called quantum numbers, and there are 4 of them. The first one is called the principal quantum number. The second one is called the angular momentum quantum number. The third one is called magnetic quantum number. And the last one is called spin quantum number. We are going to take a look at each of these quantum numbers and understand how they are used to describe each electron in an atom. Let us begin with the principal quantum number that is denoted by letter lowercase n. The principal quantum number describes the position of each electron relative to the nucleus of the atom. That is, it tells you how far away the electron is from the nucleus. A very good way to imagine the principal quantum number is to relate it to the energy levels in the Bohr's model of an atom, which means that the principal quantum number can be used to describe whether an electron is in energy level number 1 or energy level number 2 or 3 or 4 and so on relative to the nucleus of the atom. In a nutshell, lowercase n simply tells us about the energy level of the electrons in an atom. The second quantum number, which is known as the angular momentum quantum number, is denoted by the letter L, lowercase l. The angular momentum quantum number describes the shape of the region of space where a specific electron is most likely to be found. The region of space where an electron is most likely, and that is the most important phrase here, most likely to be found, is called an orbital. That is the terminology. What I am saying here is this. In the quantum mechanical model of an atom, the specific area where an electron can be found cannot be determined. However, we can predict the region of space where an electron has the highest probability of being found. And that region of space is called the orbital of the electron. Let me give you an analogy. If I were an electron during the COVID-19 pandemic, my orbital will be my house, my backyard, and the grocery store closest to my house. That is the region of space where I most likely would be found during the pandemic. There are 4 types of shapes or orbitals that are introduced at this level of chemistry. They are the s orbital, which refers to a region of space that is defined by a 3-dimensional sphere. So it is spherical in shape. There is the p orbital, which is defined as a region of space that looks like what I just drew. This is usually called the dumbbell shape. There is the d orbital, which looks like if 2 p orbitals intersect like I just drew on the screen, and there is the f orbital, which shape looks like a flower, if you will, or you can say that it looks like 3 p orbitals intersecting one another. Each of these shapes can only hold a certain number of electrons, and that leads us to the 3rd quantum number. The 3rd quantum number, which is also known as the magnetic quantum number, which is denoted as m subscript L, is used to describe the orientations of each orbital that we obtained from the angular momentum quantum number. Let me explain. S orbital is spherical, and a sphere has all possible orientations because you can assume that it faces all sides. As a result, the S orbital is said to have a unitary orientation or one orientation. P orbital is dumbbell in shape. In a three-dimensional space, Y, X, Z, the dumbbell can be aligned along the x-axis, and if that happens, the p orbital is referred to as px orbital. On the other hand, if the p orbital is aligned along the y-axis, then the p orbital is referred to as py orbital. If, however, the p orbital is aligned along the z-axis, then the p orbital is called the pz orbital, which means there are three possible orientations for a p orbital. Three orientations. A d orbital can have 5 possible orientations. So d orbital can have 5 orientations, and an f orbital can have 7 orientations. And lastly, the spin quantum number, which is given a symbol m subscript s, essentially tells us that each orientation or orbital can only hold a maximum of 2 electrons. So each orbital can only hold a maximum of 2 electrons. And if that is the case, if each orientation can only hold a maximum of 2 electrons, then s orbital can only hold a maximum of 2 electrons, since s orbital has only one orientation. A p orbital with 3 orientations then will be able to hold a maximum of 6 electrons. A d orbital with 5 orientations will be able to hold a maximum of 10 electrons, while f orbital with 7 different orientations will be able to hold a maximum of 14 electrons. Please remember the maximum number of electrons you can find in each orbital. You probably are confused about the concept of quantum numbers at this point, but I will use an analogy to explain this concept clearly to you. Imagine that an alien is coming from the planet Jupiter and the alien is looking for one Gbenga Oyedepo. That would be me. The alien doesn't know me. All the alien knows is my name. How will the alien be able to find me? When the alien lands on this planet, the planet Earth, the very first challenge that the alien would have to face is the fact that there are 197 countries on this planet. If the alien eventually finds that I live in the United States, that is the first puzzle. So that is similar to the energy levels in an atom. The second puzzle that the alien would have to solve is that when the alien gets to the United States has 50 states. The alien would have to find somehow that I live in Texas. That could be likened to the angular momentum quantum number. One thing I need you to observe is this. Every piece of information that the alien finds out brings the alien closer to me. After finding that I live in Texas, let us assume the alien lands somewhere in Texas and goes directly to a DMV, and the alien pulls my address from the DMV. That is the third puzzle. Which area in Texas do I reside in? That is my address. And that could be likened to the magnetic quantum number. And let us now say that the alien now visits my address. The next challenge the alien would have to figure out is that there are two types of people in my house. We have males and females. Therefore, the alien has to figure out whether Gbenga Oyedepo is a male or a female. This analogy is similar to the problems we face when we want to describe the location of each electron in an atom. We will first need to find the energy level, then the angular momentum quantum number, then the magnetic quantum number, then the spin. And again, remember, each new information will bring us closer to giving a good description of the electron. In the next video, we will put all of this information together and we will describe the location of each electron in what is known as electronic configuration.